All right, let's go on page 57 when we're done. Okay. So when we graph these, the first thing we need to do is look at this and try to factor, right? So we're going to factor this is going to be x minus 3, x plus 1 over x plus 1 times x plus 2. So am I going to be able to reduce anything? Yes. So I'm going to be able to cancel these out, which means I have a whole at -1. Okay? Once I've canceled it, the only thing you do before you cancel out is find the holes and find the domain, because the only thing that's going to affect your domain is the holes in the vertical asymptotes. So then my reduced function f of x equals x minus 3 over x plus 2. This is my reduced version, and that's what we use for everything else. Okay, make sense? So then I can find f of -1. That's equal to -4 over 1, so it's -4. Then my zeros come from where? The numerator, so it's 3. My vertical asymptotes come from where? Denominator, and I just wrote a v instead of an x. Sorry. It's all my vertical. X equals what? -2. Good. All right, tangency and togetherness. Okay, and there's none right here. And when this happened last period, they were like, I'm not sure that I understand it. We're going to get to one where we actually have it, so it should make a little bit more sense to you. But I don't have a factor, bless you, that has an even exponent on it, so it's none right now. Do I have a horizontal asymptote? Yes, it is tied in degrees, so y equals what? 1. And just to clarify, just because they're tied in degree doesn't always mean it's y equals 1, right? It's the ratio of the leading coefficients. So can I have a slant asymptote? No, because you can have one or the other down here, but you can't have them both. Y-intercept. Now I can find f of 0, but basically if all these zero out, isn't it just this right here? Yes. So I'm going to have 0, -3 halves. I mean, if it's not multiplied together, it's not worth multiplying that together to do that. Or I could have just done that right here as well. But if it's factored, that's when you need to really kind of think about it. All right, I'm going to rewrite my reduced version right here so that I can see it once I scroll. Minus 3 over x plus 2. All right, and we're going to do our number line. Our number line is going to be very beneficial to us on some of the ones that we do today. Maybe not this one, but we'll see. So I'm going to put on here a -2 and a 3. Then I check them. -3, when I substitute that in, that's going to give me negative over negative, which is positive overall. I can substitute in a 0, give me negative over positive, which is negative overall. Then I substitute in 4, positive, positive, positive overall. Okay, now before I shade, I've had lots of questions about the shading, and I wasn't sure why there was some misunderstanding, but I think I've finally kind of figured it out. You are not shading this like you are used to shading a number line. Usually we're like, is it greater than, is it less than, what's happening unless you actually like shade on the number line when you're doing number line stuff. Not what we're doing here, okay? That number line represents the x-axis. So if it's positive, that means all of my y values are above the x-axis. When it's negative, all the y values are below the x-axis. When it's positive, all the y values are above the x-axis. Okay? Because right now, we don't know if we want it greater than or less than. Like, we just want to know when is it positive, when is it negative. Okay? So we've got all our stuff taken care of. Now we're going to go back and graph some of the things that we know. I don't know where my paper went. Dang it. Okay. So I'm going to have to scroll up and down, I guess, because I don't have my paper to look at. I have a hole at -1, -4, and then a root at 3. So -1, -4 is a hole. I have a root at 3. Then I have a vertical asymptote at -2 and a horizontal asymptote at 1. I'm sorry, was it -2, right? Okay, x equals -2. So I'm at x equals -2. And then horizontal at y equals 1. And then what was my y-intercept? 0, -3 halves? Okay, so it's like -1.5. Okay, so do y'all agree with all that? Okay. So now I've got to figure out my graph here. So I have this part right here. Like if you look at these 3 points that I have here, that pretty much gives me my shape of what goes on over here. Would you agree with that? So we can go like, all right, I think I can get this piece drawn in. Looks like this, because I know it's got to hug that asymptote here and this one over here. But on the left-hand side of this vertical asymptote, I've got nothing. There's not a single point that got plotted there. But here's what I know. I know from negative infinity to negative 2, my function is positive. So from negative infinity to negative 2, my graph has to be up here. It's not going to be down here. That doesn't make any sense. Okay? And notice from negative 2 to 3, it was negative. So negative, 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 boom, and then it becomes positive from there on out. So I know I'm over here above the x-axis, but I still would like a point, at least one point. So I need a point over here to substitute in. So I'm not going to go crazy. If I'm here at negative 2, I'll try negative 3. Okay? So I got my x and my y, and I'll try a negative 3. So f of negative 3. That's going to equal negative 6 over negative 1. So it's 6. Would you agree with that? So I can go to negative 3, 1, 2, 3, 4, 5, 6. So I have a point right there. Well, I know that because there isn't any togetherness, since this is down here, I know I have to come in from up here. Oops. But I'm leaving the board. But when I come down here, like, does it swing out real far right here? Does it come down closer? Like, I feel like I need something else over here to help me with the shape. So let's not go with 4, because negative 4 might just get me, like, right here. It may not really help me much. So let's try negative 6. So go f of negative 6. So that's going to give me negative 9 over negative 4. So that's 9/4. 4 goes into 9 how many times? 2. Did you have a question? No, this is not a what you call it function. It's not necessarily reflected. Yeah, no, because this is not the same function we were doing that with. No, absolutely not. That was just with, if I had like 1 over x with something. What he's asking is, can I do this whole reflection thing here? And the answer to that is no. This is not the same kind of function, so we can't do that. So I got negative 6, 9/4. So 4 goes into 9 twice, so it's like 2 1/4. So we go to negative 6, 1, 2, 3, 4, 5, 6, and then up 1, 2 1/4. It's about right there. So now I feel like that's probably good enough to get, if I could actually hit that point. There we go. I still didn't hit it, so we'll just make it bigger. Looks something like that. Okay. Everybody okay with that? Any questions at all? All right. So that looks a lot like some of the ones that we graphed yesterday. We're going to get into some of these that don't look anything like those here in just a second. So let's look at number 2. We start by factoring, right? So this is going to give me x minus 3 times x plus 2 over, and then what would the denominator factor into? X plus 4 squared. Very good. This is a perfect square. If I take the square root of 16, it's 4 times 2 is 8. So that tells me this is x plus 4 squared. If you factor it and you end up with x plus 4 times x plus 4, that's fine. Just make sure you end up putting it as x plus 4 squared before all is said and done. I can't reduce anything. This is the function that I'm working with. So are there any holes? No. What are my roots? Negative 2 and 3. Vertical asymptotes. X equals what? Negative 4. Tangency and togetherness. Okay, get out your little radii foldable here. I should have told you all to do that at the beginning, and I didn't. So get out radii. Come on. The blue thing from yesterday. Come on, come on. I'll wait on the table that's ignoring me. Yes. Oh, poor thing. She probably didn't make it through the day. I need to call her. No. Okay, tangency and togetherness. That's that t squared, right? Okay, so we have a factor that has an even exponent, and it's in the denominator. So what does that give us? togetherness, okay? You may not understand what that means yet, but it gives you togetherness. Like, we at least know that much. So we're going to say this gives me togetherness at that x equals -4. When we get down here, I'll explain to you why that's important to us and what that means, okay? But we are going to have togetherness based on that. So horizontal asymptotes, do I have any? Or do I have one, rather? Yes. It's y equals 1 because they're tied in degree, and that is the ratio, which means we're not going to have a slant asymptote. Okay. Y-intercept. You had -6/16, which is then what? -3/8. Then I'm going to rewrite this. And I get x minus 3 times x plus 2 over x plus 4 squared. Okay. So now I'm going to scroll. So now on my number line, I'm going to put the -4, the -2, and the 3. -4, -2, 3. Right? Okay, so if I substitute in a -5, -5 is going to give me negative, and then in the denominator, since I'm squaring and all I'm using is real numbers, am I going to get something positive every single time? Yes, so the denominator is going to give me something positive every single time. So this is positive. If I substitute in -3, it's going to give me negative, positive, so it's positive overall. If I substitute in 0, it's going to give me negative, positive, negative overall. 4 would give me positive, it's positive overall. So when I shade, this is a positive, negative, positive. Okay. Now let's think about what this means. Our vertical asymptote is at x equals -4, right? Our number line is like our x-axis. Here is my vertical asymptote. What the togetherness means is that these are both going to infinity on either side of this asymptote. Back here and on all the other ones that we have graphed, notice on either side of the vertical asymptote, they're going in opposite directions. Togetherness means that they're going in the same direction, and that's going to help us with our graph. Okay. All right, so then we have that. Let's go ahead and start plotting what we can plot over here. So I know that I don't have any holes. I have roots at -2 and at 3. Vertical asymptote at x equals -4. Togetherness at x equals -4. We'll get back to that. Horizontal asymptote at y equals 1. Oh, you know what, guys? Let's just hit the pause button here real quick, okay? We're going to rewind back to the first one because I forgot to do something. So, rewind back to number 1. This is what happens when I have like a lunch break in between when I'm teaching. I forget what I'm doing. All right, so we were all okay with this graph, right? But here's the thing. One thing that you didn't know necessarily before this year was that you can cross a horizontal asymptote. You'll never cross a vertical asymptote because that affects the domain. But you can cross a horizontal asymptote. But we don't know if we do or not here. Like based on everything we did, this is the best we got. But if this does cross this asymptote, then that means at some point the function is going to have a y value of 1. You with me on that? So your horizontal asymptote is y equals 1. This is your function. If the function would have to have a value of 1 here. So if I do x minus 3 over x plus 2 and basically substitute in 1 for y. Say, all right, when y is 1, what is x? See what we get. So now I'm going to multiply both sides by x plus 2, and I get x minus 3 equals x plus 2. Then when I subtract x from both sides, I'm left with -3 equals 2. Is that ever going to be true? No. So can this function ever equal 1? No. So does this function cross that asymptote then? No, it does not. Okay, so we're going to have to check now. All right, so let's jump back over here. I forgot to do that one. Okay, so let's see, where did I stop when I realized what I was doing? I got these two in there. I got my horizontal asymptote. Okay, then I have a y-intercept at 0, -3/8, so that's like almost -1/2. It's right there. So here's what we know. I only have 3 points on there, and I've got 2 asymptotes. And I know that from negative infinity to negative 4, my graph is positive. So from negative infinity to negative 4, it's positive. It's above the x-axis, all right here. But I have no idea where. So I need at least 1 point here. So we can try, since this goes to negative 4, let's do negative 5. Okay. So if I find f of negative 5, this is going to give me negative 8 times negative 3 over negative 1 squared. So it's just 1. So basically this is 24. Does that really help me any? No, it does not, because it's off my graph. So let's do negative 6. F of negative 6 gives me negative 9 times negative 4 over negative 2 squared. So what's that going to give me? Did I do that right? Yeah, it gives me 9. Okay, I was thinking I was supposed to get something else. It gives me a positive 9 or a negative 9? Positive 9, okay. So negative 6, so I can go to negative 6, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, that's all fine and great. I got a point, but that doesn't exactly give me anything. So let's do negative 8. See if I can get another point over there. Because I still don't know. I don't know when I come down if it comes down real close to this or if it swings out real far or exactly what's happening. So f of negative 8, that's going to give me negative 11 times negative 6 over negative 4 squared. That gives me 66 over 16, which is 33 over 8. Okay, how many times does 8 go into 33? 4 times with 1 left over, so it's like 4 and an 8. So I can go to negative 8, and then 1, 2, 3, 4, and a little bit. So with those 2 points, I know it's going to come down like this, and it doesn't, I mean, yes, it's going to come close to your asymptotes eventually, but right here, it's, you know, there's some space in there. Now, let's talk about this togetherness thing. Because between negative 4 and negative 2, negative 4 and negative 2, my function is positive. So we've got this togetherness. We're going up here on this side of the asymptote. This side, it has to come down from here. So it's going to come down and hit this point right here. That's when it becomes negative. So clearly, I'm crossing that asymptote at least once, right? Because it's got to come down and hit that point. And then it's going to come down here, and it's going to have to come back up. Well, when it comes back up, I don't know if it's going to come back up over this asymptote and then back down, or if it comes up and it hugs it from underneath. So we're going to have to figure that out. All right? So we figure that out by seeing when it equals 1. I know it equals 1 at least one time, right? So my function, which is x minus 3 times x plus 2 over x plus 4 squared, I'm going to substitute in the y value of 1. Not because I always do 1, but because that's what the asymptote is. It's y equals 1. So then I solve this. I'm going to multiply both sides by x plus 4 squared. So we get x minus 3 times x plus 2 equals x plus 4 squared. The left-hand side is x squared minus x minus 6, and then x squared plus 8x plus 16. We shouldn't have to think real hard on that, right? Because we factored it to get that. So now when I subtract x squared from both sides, those zero out. Now I'm going to, what? It's minus 6. That's what you're asking me. Okay. So I subtract x squared from both sides. So now I'm going to add x over here and subtract 16 over here. So I get negative 22 equals negative 9x. So x equals 22 over 9. So that is an x value of an ordered pair. The x value is 22 over 9. I got that by substituting in a y value of 1. Oh, shoot. I add x, that should be a positive 9x. Thank you. Whoop, whoop. There we go. I even said add x, and then I magically made it negative. Okay, but my x value I get is negative 22 over 9. You okay with that? My y value is 1. I only got one x value for that y value of 1. So how many times does that function cross that asymptote? Once. And we know exactly where it is. It's at negative 22 over 9, 1. right? So 9 goes into 22 twice with 4 left over, so it's about like 2.5. So I can go to negative 2.5, 1, and then there's that point right there. So here's how I know what to do. By my sign chart over there, from -4 to -2, it's positive. Plus I have togetherness, so it's going to have to come down like this, and it hits that point. There's all the positiveness, right? It's negative between -2 and 3. So it comes down here, has to go through that y-intercept, and it's going to come back up. Then from 3 to infinity, it's positive. But I know for sure it doesn't go over this asymptote because I only got one value down there. So when it comes back up, it has to hug the underneath of the asymptote like that. There's no guessing on any of that stuff. You have to know all of these pieces. 90% of this is from Algebra 2. Okay? And you're putting it all together. What questions do you have? Because when we went to find where it actually is equal to the asymptote, it was only at one point, and it's that point right there. So it cannot go back over that asymptote because it doesn't intersect it again. Yeah, and it goes and it gets close, because that's the whole point of an asymptote in the end behavior. We just don't know if it's coming from the bottom or it's coming from the top. Okay. Everybody okay with that? Yes? All right, let's move on to the next one. So we factor, and we get x minus 3 times x minus 1 over x minus 2. That is my reduced version because I cannot reduce anything, so there are no holes. Okay. Are there any zeros? Yes, 1 and 3. Vertical asymptotes, x equals 2. Any tangency or togetherness? No, because I don't have anything with exponents. Horizontal asymptotes? No. Which means that opens the door for a slant asymptote. Is the numerator 1 greater in degree? Yes. So that now I need to divide. Would you choose to do long division or synthetic division here? Synthetic, me too. So get 2. And then that leaves me with 1, -4, and 3. And remember, you always get a remainder. If you don't, then you didn't reduce before like you were supposed to. -4, my remainder is -1. So that means my slant asymptote is y equals what? X minus 2. And what is my y-intercept? -0, -3/2, right? Okay. So now, I'll rewrite this down here so we can see it. F of x is equal to x minus 3 times x minus 1 over x minus 2. So on here, I'm going to put 1, 2, and 3. So when I substitute in 0, I get negative, 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 which makes it negative. I substitute in 1.5, I get negative, positive, negative, which makes it positive. 2.5 is going to give me negative, positive, negative. No, it's not. Yes. No. What did I do wrong? 2.5. Oh, that would make that positive. Sorry. Duh. 2.5 minus 2 is a positive number. So this is negative. Then 4 will give me positive, 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 positive overall. So then I shade. This is negative, this is positive, this is negative, this is positive. All right. So then we start plotting things. I have no holes. I have roots at 1 and at 3. My vertical asymptote is at x equals 2. My slant asymptote is at y equals x minus 2. Is that going to be easy to graph or difficult? Easy. My y-intercept is at -2. My slope is 1. So make sure you sketch it in correctly. As somebody said earlier, this is why it's important to always have your ID on. This is the reason right here, so you can get straight lines. I feel like y'all can't. These are hard to see. So put them in yellow as well. What's the question? Oh, okay. Got it. It's the y-intercept of my slant asymptote, but not the y-intercept of my graph, yes. All right, so then the y-intercept for the function itself, I guess I should ask that differently, right, is 0, negative 1/2, so you are right here. Okay. Huh? What's the question? Okay, but are you still confused? You got it? Okay. All right, so from negative infinity to 1, your graph is negative, right? So it's negative until it gets to 1, and then it's positive from 1 to 2, okay? And so really just with having those 2 points there and understanding asymptotes, that's enough. And it should look like this. We're taking the test. Then so that was negative, so from 2 to 3, from 1 to 2, it's positive. From 2 to 3, it's negative. So here's 2 to 3, okay? And I know it's not going to be up here like this, first of all, because I have this point. But even if I didn't, I don't have any togetherness, so it can't come from up here. It's got to come from down here. So it's going to come from down here and hit this point, and then it's positive from here on out going along that asymptote there. And there's your function. So it's not a guessing game. It's about what do you know and what is the only thing that could possibly be happening here. Okay. Go ahead. Well, it could cross it. We're not done. We're going to see if it can cross it. It can't. Yeah, you can cross a slant asymptote. You can't cross a horizontal asymptote. Sorry, you can't cross a vertical asymptote, but a slant asymptote and a horizontal asymptote you can. So we got to see if it does. Like I went ahead and graphed it in. If I got to erase it, I'll erase it. So we got to see. We think this is what's happening, but maybe it does cross it. Like maybe it comes up here and then it crosses over and then it hugs it from up here. So we got to see when this is a system of equations. It's the whole concept of a system of equation that comes from Algebra 1 and is hugely heavy on the SAT. When you have a system of equations, graphically, it's where they intersect, right? So I want to know, does my function, which is x minus 3 times x minus 1 over x minus 2, does it ever intersect my asymptote? So we were setting it equal to 1 on the other ones. My asymptote isn't 1 here. What is it? X minus 2. So I set this equal to x minus 2 to see when they intersect. Okay? Because they're both equal to y, so you're substituting it in for y. So now when I multiply both sides, I'm going to get x minus 3 times x minus 1 equals x minus 2 squared. So I multiply this back together, and this gives me x squared minus 4x plus 3, and that's equal to x squared minus 4x plus 4. Then I solve. I subtract x squared from both sides, and they zero out. When I add 4x to both sides, those zero out. So I end up with 3 equals 4. Is that ever going to happen? No. So does my function ever cross my asymptote? No, it does not. Okay? But you're not going to know that necessarily without checking. Okay? Unless you just happen to get a random point that, shows you that that's what's happening there. Okay? All right. Last one. Were there any questions on that one? Okay. So I factor, and I get negative 6 in the numerator. The denominator is x minus 3 times x plus 2. And this is my function. Okay? Because I cannot reduce anything, so there are no holes. Do I have any roots? No. So do I put none? No. I put the empty set, right? Okay, vertical asymptotes. Oh, I keep writing a V. Why do I keep doing that? It's x equals negative 2 and x equals what? 3. Okay. Is there any tangency or togetherness? No, none of my factors have any exponents on them. Do I have a horizontal asymptote? It's bottom heavy, so that means y equals 0. Do I have any slant asymptotes? No, because I had a horizontal one, right? What's my y-intercept? 1. So it's 0, 1. Okay. So let me scroll, and then let's work on our number line here. So this is f of x equals -6 over x minus 3 times x plus 2. So on my number line goes a -2 into 3. And remember, what you are looking for here is just signs. What are the signs? Is it positive? Is it negative? When I substitute stuff in, I'm not actually substituting anything in from the numerator, but the numerator every single time gives me a what? Negative. So the numerator is negative no matter what. Then I substitute in like a -3. That'll give me negative, negative down here. So overall, this is what? Negative times negative times negative is negative. Between -2 and 3, I can use a 0. The numerator is negative no matter what. The denominator would then give me a negative and a positive. So that's positive overall. 4, if I substitute in 4, that'd be negative in the numerator, and then positive, positive, so that gives me negative overall. When I shade it, this is negative, this is positive, this is negative. Okay, everybody with me? So let's plot what we know. We have no holes, we have no roots. We have a vertical asymptote at x equals -2, and one at x equals 3. Right? No tangency or togetherness. I have a horizontal asymptote at y equals 0. And then a y-intercept at 0, 1. Well, that doesn't really tell me a whole lot about my graph. What did I do? Guess I moved this somehow? I don't even know how I did that. Okay. All right, so here I know from -infinity to -2, my function's negative. So it's down here somewhere. And it should look something like this, but I need to know exactly kind of where's the point to guide me a little bit. So the asymptote's at -2. Let's use -3. So I'm going to find f of -3. When I substitute that in, it's going to give me -6 over -6 times -1. So what does that give me? -1, right? So I can go to -3, -1. Do you feel like that 1 point is enough, considering where it is? Yeah, I think it's probably enough. So go through here, boom, like this. All right, so then I know from -2 to 3, between these two vertical asymptotes, it's positive the entire time. So, and I don't have any togetherness, so I know since this is going to -infinity here, I have to start up here and come down. Well, when I hit this point here, am I going to keep going down over here like this? No, because it's positive the whole time. I know that. It's not going to drop below 0. So I know I have to come down at least this far. This isn't necessarily the minimum, but I got to come down at least that far, and then I'm going to have to go back up. So it's going to have to look something like this. And if you're not sure, you could always pick another point and plot another point in there so you can see what's going on. It looks like a parabola, but it's not a parabola. It has a parabola, shape. It's the aura of a parabola, but it's not really a parabola. Okay? And maybe this, like I said, this kind of looks like my minimum. Not necessarily the minimum, but it's, good enough to get the pieces in there. Then from 3 to infinity, it's negative. So I know the rest of it has to be down here. And the shape's going to look something like this, but I could use another point. So let's use 4. So if I find f of 4, that's going to give me -6 over 1 times 6, which is -1. So I can go to 4, -1, and put a point there. Now, I have a horizontal asymptote. It is possible to cross a horizontal asymptote. I need to know if this one does. Do I need to test it like I did the others? I don't. Why not? Because since it's at 0, if it went above that asymptote, it would have to become positive. And I know that this is negative the whole time. Does that make sense to you? When your horizontal asymptote is on the axis, your sign chart can tell you whether or not you're crossing that asymptote because you know when it gets positive and negative. But when you move the asymptote, then you got to check it because your sign chart doesn't help you. Okay, does that make sense to you? So I know for a fact from negative infinity to negative 2, it's negative the entire time. So there's no question that it doesn't go above here. From 3 to infinity, it's negative the whole time. So there's no way it would have to become positive to go above it. Okay, and you're done. And what? It would give you what? Oh, yeah, I'm going to give you a root. Yes. Even if it did cross, it would give me a root. But just because I have a root doesn't mean that it crosses because it could bounce back down. But yes, you're right. All right, what questions do you have? Anything? All right, so your assignment and your notes look very similar to each other because I was trying to make the blanks big enough for you to write in and then the graphs big enough for you to graph in so things weren't tiny.